Special relativity. How did Einstein obtain his ambiguous relation of light reflection x prime equals x minus v times t in 1905 article? Spacetime transformation used. We will use the same symbol of spacetime transforms Einstein had used. Frame spacetime coordinates are k, x, y, z, t, and frame spacetime coordinates are omega, xi, eta, zeta, tau. Einstein mental experiment. Einstein imagined a light ray emitted from the origin of frame k at time t0 along the x-axis to reach a mirror located at x prime equals a in frame k at time t1. The ray reflects back and reaches the origin of frame k at time t2. We have three events. Emission at the origin t0, x0. Reaching the mirror at t1, x1 where. Reflecting back to the origin at t2, x2 where. Over the axis of time t1 is the middle of segment t0, t2, hence according to analytical geometry. Emission at t0 is equal to 0, x0 is equal to 0. In frame k and at time t0 is equal to 0, a ray of light is emitted at the origin x0 is equal to 0 as shown. The corresponding coordinates in frame omega. Reaching the mirror at t1, x1 equals c times t1, where t1 equals a over c. Point 1 has the coordinate c times t1, t1 in frame k. The corresponding coordinates in frame omega in terms of t1. Also point 1 has the coordinates t1 equals a over c, x1 equals x prime equals a. The corresponding coordinates in frame omega in terms of a are. Dividing. Hence, relative to omega, from time t0 to time t1, the light has traveled from point 0 to 1. L as measured in omega. Distance the light has traveled in frame omega measured by k. Relative to k and at time t1, the origin of frame omega location is. Relative to k and at time t1, the end of light ray location is. Relative to k and at time t1, the end of light ray location is. Hence, this relation, which contain c minus v, does not violate the constancy of the speed of light since we are measuring both ends of light ray at the same time. Reaching the origin at t2, x2, where x2 is equal to 0, t2 is equal to 2a over c. After the light ray reflects at time t1, it will return back to the origin at time t2 as shown. The coordinate of this point, 2, in frame k are 0, t2. In frame omega, the coordinates are. By dividing. Also point 2 has the coordinates t1 is equal to 2a over c, x2 is equal to 0. The corresponding coordinates in frame omega in terms of a are. Relative to omega, from time t1 to time t2, the light has traveled from point 1 to 2, a distance I2 minus I1. The time period, in frame omega, the light takes to travel from point 1 to 2. Distance the light has traveled in frame omega measured by k. Let Fg be the length of segment in frame omega as measured by k when the light ray return from the mirror to the origin. We need to measure the length of Fg at time t2. Therefore, we need the coordinate of f and g in frame k at time t2 to find xg minus xf. To find xg, it is very clear from the figure that to find xf when the light hit the mirror at point x equals a at time t1 equals a over c, the coordinate of point f was mapped into frame omega and was found to be a time t2 is equal to 2a over c in frame k. The coordinate of point f in frame omega is psi f. The coordinate of point f in frame k at time t2 is xf, and the corresponding time is tau f at point f in frame omega. The relation between coordinate xf and psi f at time t2 is equal to 2a over c is. But the coordinate of point f, psi f, at t2 is equal to the coordinate of point f, psi f, at t1. Substituting both coordinates of point f, psi f. Isolating xf, which can be written in terms of t1 or t2 as solving for x1. Einstein named x1 as x prime, hence the previous equation can be written. It seems that this derivation explains how Einstein used the transform x prime equals xf minus v times t1 in his ambiguous derivation of spacetime relations. He simply used Lorentz transforms to find it out and used it again to derive Lorentz transforms. This is a quote from Einstein article where he's used the formula x prime equals x minus v times t. On the Electrodynamics of Moving Bodies by Albert Einstein, June 30, 1905. The time registered at point F in frame omega. Hence, the distance the light has traveled in frame omega as measured by k at time t2. Relation between tau 0, tau 1, tau 2. We have found that. Hence, substituting in t1 equals 1 over 2 t0 plus t2. Isolating tau 2. Relation between psi1, psi2. We have found that. Hence, substituting in t1 equals 1 over 2 times t0 plus t2. Isolating psi2. Note: the term 1 minus v over c divided by square root 1 minus v square over c square can be written as